Okay, we're back at it here. We got chapter 5, activity 1. Okay, there's a lot of examples, and then they give a solution. So my suggestion is the best way, of course, best way to go about that, Kenda, is to, on each example, put a piece of paper over like I would take this blank paper here and put it over the solution. Work your own solution, even if it's one of those proofs. It'll really help you. Like the first one, I think, is the diagonal of a square is in the area of a square with the diagonal, right? In reference to the diagonal. Okay, so getting the area of a square with the diagonal as the only other variable. That's a great exercise, and there's several more of them. And I won't do those since they give the solution. I will say that we just finished trigonometry, which you might think is more difficult than this. And these are just little puzzles. And then now that you know your trigonometry, you can use sine, cosine, tangent, Pythagorean theorem, all that to find these areas. Okay? And maybe I'll give a few more little examples, but I think you know how to find the basics of the area of a rectangle, the area of a parallelogram, the area of a trapezoid. I'll show my little ways of remembering those and making sense of those. And then we'll just work these activity exercises. Okay, so you draw this and check it out. It's a strange one, and you'll see why if you start looking at it and breaking it down. It doesn't seem to make sense, but please do this one. It does work out. It's pretty interesting. You might think about redrawing it. That's what I did. Okay, so you draw it, solve it. Ready, go, and pause this video. Okay. All right. Hopefully you got a solution, and then now I'll solve it, and we see if we get the same thing. So here we have this. So what shapes do we have here? Got a triangle stacked on top of a parallelogram. Okay, this line, opposite sides are parallelogram. So everything, you're going to take all these figures and cut them up into triangles and rectangles, right? Because triangles and rectangles, we know the area of. And, well, this parallelogram is pretty darn simple, right? You're giving the altitude. So anytime you're finding the area of a figure, of a plane figure with straight lines, if you want the area of it, you do the altitude. It has to be the height, the altitude, must be perpendicular to the base. So you don't multiply the 5 times the 10 to get the area. You multiply the 3, the altitude, the height. So this one's real simple. It just wants us to find the area. So we can get the area of this is easy. Area is height times base, altitude times the base. 3 times 10 equals 30. So then, how are we going to find this guy? The area of, and it gives us, there's a right angle up here, and parallelogram, okay, opposite sides are equal. So this is 5 over here, and this is 10 here. So we look at this, we have a, and maybe you've already figured this out. I hope you did. And I'm just repeating what you did, possibly. So here, what part of this triangle up here? So now we just find the area of this triangle, and we're done. The area of this triangle, we have this. It looks like the base. I'm not going to use that as the base, because I would have to find this height anyways. I don't know what that height is, and how would I find that height? What's another thing we know about parallelogram? Well, I have here, if I extend these lines, the base here and this top one, if I extend those, then I have parallel line. I have 2 parallel lines and the transversal. So this is going way back. I don't know when you did all this parallel lines and, the congruent angles and parallel lines. So he's transversal here. You got, what is this called? I forget the names of these here. Corresponding angles. There we go. Corresponding angles are congruent on parallel lines. So this angle and this angle are equal, and I got this is 3. I know this is, I can move this altitude around, and then I got this. I've got a triangle over here, and this is a right angle, so I got a little right triangle. So I don't even have to find this missing length here, right? Now I'm doing it a different way than I did it a while ago, practicing before I did this. But here we go. I want to find this angle, so then I can find this angle, so then I can use my trig relationships and find this side and this side, and then I'll have the base times the height, right? This is either this is the base and this is the altitude, or this is the base and this is the altitude. It doesn't matter. I have a right triangle. So let me draw this over here. So if I got this right triangle here, if I spin it around, let's see, I've got this is triangle ABC. Okay, so I don't know how, Kenda, I don't know how, if your brain likes doing this, moving these shapes around. But if I take the center of this hypotenuse, right? This is a hypotenuse of this triangle. If I take the center point of AC, and I rotate 180 degrees, I rotate ABC, then I wind up with this here. I wind up with this, let's just call this B prime here, I guess you'd say, huh? So, and now I've got A prime would be matched on top of C, and then this, and C would spin around, then there'd be a C prime over here. Do you see I got a rotation? So the area of this triangle is half the area of the rectangle, right? There's two congruent triangles, right triangles, to make a rectangle. And we know the area of a rectangle is just base times height. So once I find the base and the height, I multiply them, divide by 2, and I'll have the area of this triangle. Okay, so I'm going to take, so I've got this, I want to find this angle, then I'll know this angle, and I'll use this angle to find these sides given this hypotenuse. So I have, what should we use? We got an opposite side and a hypotenuse, so let's use sine. Sine of, I don't know, let's call it theta, or sine of angle D. We could say sine of D equals opposite over hypotenuse. So angle D, the measure of angle D equals sine inverse of 3 over 5. Okay, so just stick that in my handy dandy calculator. And this, one thing that really bothered me about this drawing is it's so inaccurate. I don't know if they meant it to be horribly inaccurate. Sine inverse of 3 divided by 5 equals. All right, you memorize a lot of things, so you probably recognize that angle. Which special angle is that? What 36.9 or 37 degrees? So if you had here's the other way to get it. You could find this length here. 3 squared plus blank squared equals 5 squared, right? You'd have a what kind of triangle? 3 squared plus b squared equals 5 squared. A 3, 4, 5 triangle. So this has to be 4. And so this drawing is horrific because it really messes with you, because obviously this angle, and I think I did a pretty good job copying what they drew. This angle is not a 36 degree angle. It's more like a 60 degree angle or 65 degree angle. So it makes the drawing completely wackadoo. I drew it, so I grabbed some graph paper and I drew it. And if this, I drew this length 10 squares. and then I did a 3 and a 5 here. Well, that makes this a 3, 4, 5 triangle. It has to be that way, right? And so then that just leaves 6 here. So you got a little square 6 by 3. And then you got these two triangles. This would be a area of 6 and area of 6, right? And there'd be the 18. That would get you your 30 for this guy here. And then this triangle up here, there's actually two ways you could get this. Anyways, now we know, see, this is more accurate. This is your 36.9 degree angle. 36.9 degrees. So you can get the correct answer without ever getting the drawing anywhere near correct. So that is more accurate to what the drawing should be. So this drawing is so out of whack that it makes this look like the long side and that looks like the short side. But if you look at this, and then you can think about, if you go ahead and draw this a little more accurately, then you can think about, well, if this is a different lesson, similar polygons, but this shape, this triangle, this has a right angle, and this one has a right angle, and they both share this angle. So this angle and this angle have to be congruent. So all the angles are congruent. So these are similar triangles, and this hypotenuse is 10 and this one is 5. So this one is twice as big. So you can break it up. You can see that this angle's, each side is twice as long. So the area is how much bigger? 4 times as big, right? If the sides are twice as big, then the area is 2 squared, 4 times as big. So you can see how much bigger this triangle really is than this one. So their drawing is just a sketch, and it's very inaccurate. But you still use the numbers that they gave you to get the correct answer. So, all right. So what are we going to do here? I have opposite over hypotenuse and adjacent over hypotenuse. So over 10, well, let's put it in there, and you'll see this better be, I better be taking this same triangle and spinning it around and moving up here, and this is really going to be the short side. Okay, so because it's opposite the smaller angle, this angle is actually bigger than that angle, right? 90 minus 36.9. Okay, so let's use that, we'll write it 36.8. Let's just use 36. We could go with 36.9. Let's just do that. So here we go, and we'll get real close, and then we'll see that it's actually a 3, 4, 5 triangle flipped upside down. So, well, let's go ahead and do that. So this side would be, to find this side, I'm going to take opposite over hypotenuse. I'm going to say sine of 36.9 equals, I don't know, call it x over 10. So 10 sine 36.9 equals that. Okay, so 10 sine 36.9. 6.00000. Well, like I say, it's the same. If you recognize this similarity, then this is just 6. This side is 6. And it'd be, instead of being 6 squared plus what squared equals 10 squared, do you remember that? It's got to be double. So this side, double it is 6. This side, double it is 4. Can you see that? I hope. So anyways, now you got 8 times 6 divided by 2. The area of this is 8 times 6 divided by 2, 24. So the area of the whole thing, the area of EDCB is 24 area total, 24 plus 30, oops, plus 30, 54, maybe it's centimeters, I don't know what each side was, but anyways, 64 square units. Okay, whoa, long video again, but, all right, cool. good luck. I'll do the next one. We'll do 3. I'll do 3 today. I'll send you 3 videos in this little playlist, and you can work on those.